Hello everyone, welcome to Yourpedia Education. So as you know, form filling of BEL now finished. I think it is last date is 14. Now form filling is done now. Everyone will have around you can say 2 months, right? After 15th of Jan, anytime this exam will come, right? They will give you the short notification of 15 days. They will tell you that at this date you will have the exam. So now you are having 2 months, right? Be focused on that thing. You are having 2 months and start your preparation accordingly for BEL exam. It is not difficult exam. I am again saying that thing. It's easy exam, but it is have to cover vast things, right? Like today I'm coming here, that is introduction to radar system we are going to discuss in detail. But one thing remember, right, like this radar, GPS, and there are several topics which was asked in that exam in past, right? So if you want to prepare for this exam, you can join our module. We have already finished, right? We have already finished network theory and control system. Now from the Monday onwards we are going to start digital electronics and signal system. If you want to join, you can join before Monday, right? Because the next fresh subject will going to start and you can start your preparations. And the subjects which already covered, you can watch the video lecture for that one. And also we already make a group for the candidates who are enrolled with us, and in that group, yeah, you can ask your query to that teacher if you have any doubt regarding the recordings, right? If you didn't understand any concept from the recording, you can ask to that teacher, right? We will provide that facility for everyone. So basically my main concern is that you are having only 2 months. How to prepare for that one? Which subject I have to be focused more, right? And main thing is that the student think that I can leave this topic, I can leave this subject. No, this exam is not like that. They can ask the question from anywhere. Like this time they asked the question from VLSI. They never asked any question in the past from the VLSI. They asked some questions from there also. So it will be depending on that thing, that you have to cover everything, right? Let's start this topic that is called as radar. So if you want to prepare for that exam, I'm again repeating, you can join Yourpedia, right? We are already going on the live classes for this exam. The first thing which in many exams they ask the thing, what is the radar? The full form of radar. The radar is what? Radar is what stands for radio detection and ranging. Radar means what? Radio detection and ranging. That means it is radar, right? And radar is based on that we are sending a EM wave towards an object. As you know, when we are sending a EM wave towards the object, and let's take object is always having some metal part, right? So I'm discussing the basic concept of radar. This is your object. Let's take this object is moving towards you. You are having here your antenna which is transmitting the EM wave towards this object. So we are sending a EM wave towards this object having some metallic part. As you know, as you already studied in electromagnetic field theory, that the metal are the good reflector of EM waves. So when EM wave reaches here, that will be reflected back from this object, right? They will reflect back to this from this object, and at the same time we are having a transmitting antenna or receiving antenna here. The receiving antenna will receive that EM wave which is coming from that object, and we think that this transmitted wave, this we are receiving. If we are not receiving any wave, it means there is no object right now. If we are receiving back any wave, it means there is an object. Now we have to find the speed of that object. So we are continuously observing that one. There are several types of radars which are depending on their working principle are different. So they are generally detecting the object. The object is coming towards Earth, object is going far away from that, how much is the size of object and everything, right? That will be done by the radar, right? The basic concept of radar is we are sending a EM wave towards the target reflect back that EM wave, and we can easily detect that target. But one condition, the target should have a metallic part, because we are generally tracking the what we can say that the planes and everything, right, that are also already have the metallic part inside that one, which will reflect that EM wave, right. That is all about this one. The key functions of radars are detection if an object exists in a specific direction. Ranging means what? These are the functions. Ranging means measuring the distance between the radar and the object, right. The first thing is we are trying to detect an object. Yes, that's the thing. Yeah, we are continuously observing the space, right. We are sending the EM wave, we are waiting for the reflected wave. If the reflected wave reaches to us, then we will understood that there is an object. That is called detection. Next thing is ranging. Ranging means we are measuring the distance between object and the radar. Next is tracking. Tracking means continuously following the you can say the target position. The currently target is here, right. It is moving in this direction, it is moving in that direction. That is called as tracking. And the last one is identification. So identification means what? Which type of signal, which type of EM wave it is reflecting. Based on that one, we are thinking that yeah, this is that object, this is that object. So we can identify that which type of object is this one. So radar is this one, right. This is the main function of the radar. This is the basic concept of radar you are seeing. This is the radar antenna, right. Antenna transmitting, this is the target. As the wave reaches to this target reflect back that ways. This is called echo pulse, and echo pulse will be received from the same thing, right. This is the history of the radar in 1886, how the radars will evolve around World War II. You can read it, right. Yeah, this is not that much important. The basic principle of radar operation, yes, the basic principle of radar is that generally we are sending the EM wave will travel with the speed of light, 3 into 10 raised to power 8, because we are using the radar in free space, right. We are using the radar in air to detect an object. So here the wave will travel at a speed of 3 into 10 raised to power. When this wave encounter an object, the part of the energy is reflected back towards the radar. The radar received and detects the return signal and measure the delay between the transmission and reception. The distance of the target is calculated. So basically, this is the object here. We transmit a EM wave from here. Yeah, we transmit it right now. It will go to this one. It will reflect back to us. So we understood that we send this EM wave before 2 milliseconds, and it will go to object. We will receive back it after 2 milliseconds. So what we understood, so that the time taken by the EM wave to travel from antenna to the object, from object to the antenna back is how much? 2 nanoseconds. So it means the wave take 1 nanosecond to reach that object, right. Let's take 2 nanoseconds is the return time of that EM wave which we send it by us. So it means it will take how much time? It will take it was take 1 nanosecond from to reach from the antenna to that object. So easily we know the speed of light, we know the time, we can easily detect the distance between the objects by this formula, right. Yes. So the pulse repetition frequency, this is called pulse radar. So basically we transmit first pulse, pulse radar generally we say. We transmitted first pulse, we wait for the next pulse. How we decide that? After how much time we have to send the next pulse. See, basically every radar has its range, right. Let's take this radar is designed only for detecting a object of 300 kilometers. So we transmit a wave, we know that it reaches to that point and come back. If any object is at 300 kilometer, it will be come back to us after this time, right. Let's take it will take 1 nanosecond to reach there, 1 nanosecond to back there after for 300 kilometers. Understood my concept, right. I'm sending a wave. I know that this is the maximum range of this radar, that is 300 kilometer. So I am sending a wave, it will go there, it will come back. I know that this will take 2 nanoseconds. So then I send one signal, I wait for 2 nanoseconds. It will be reflected back. If I didn't receive anything, I will send another pulse. after 2 nanoseconds. So that's why this is called as how we can send the signal, after how much time should I send the signal, right? The pulse repetition frequency, the number of pulse emitted per second, right? Bandwidth determine the angular resolution, bandwidth affects the range of resolution, right? Yeah. Block diagram of major components, you already see radar, right? Emitting energy, targeting, and that's all the things, right? Transmitter will transmit, generate the power. Antenna will transmit that. Duplex means what? Generally there are two things, there are two types of radar. One is having transmitter and receiver separately, right? There is no need of duplexer, right? We are having transmitter and receiver separately. This antenna is doing transmitting, this antenna is doing receiving, that one, right? But some radars are using the same antenna for transmission, like this pulse radar. If we talk about previously, that pulse radar, that is using what? That is using only single antenna. I am transmitting right now, I am transmitting that one, right? I transmit a pulse of 1 nanosecond, then I have to wait for the echo. How much time I have to wait? On that time it will be work like a receiver, the same antenna. Then again I am sending a pulse, then I have to wait for echo. If echo will come, it will receive that echo. So here there is a term that is called as duplexer. Duplexer means switching the antenna connection between transmitter and receiver, protect the receiver from high transmitted power. Receiver amplifier weak signal, echo signal, and convert that into a usable form. Signal processing, from that signals we have to extract the information, and we can extract that information by using the signal processing. Display and indicators. So display, we are displaying that this object is here, like that. We are using generally the software for that one. Timing and synchronization, you need to synchronize the signals, right? This is the signal flow for that one. First transmit, duplexer send that to antenna send back to target, then target reflect back an echo will be received by the antenna send that to duplexer. Now duplexer send that signal to receiver. After receiver we are having signal processing, then we are having a display there, right? This is the complete thing, a complete block diagram of this one. Radar range equation is tells us that how much power we have to receive after transmitting this much power. This is the gain of transmitting antenna, gain of receiving antenna. This is the range, means this is the distance between the transmitter and receiver. Lambda is what? Lambda is the wavelength. Sigma is called as the radar cross section of the target, and L is generally the constant there, right? L is the system losses, right? Not constant, that is system losses there. Okay, this is an example. If a radar is having 1 kilowatt power at 10 gigahertz, what is the gain of 30 dB and detecting of an aircraft to cross section? Receiving power is 50 kilo. Yes, that formula, and then we will solve it, right, easily. Yeah, types of radar, this is important. Based on waveform, we are having two types of radar. The first is pulse radar, then continuous wave radar, and then frequency modulated continuous wave radar, right? In pulse radar, transmitting a discrete pulse, which we discussed right now, measuring the range from the time delay. With the help of time delay, we will measure the range of that one. Continuous wave radar, transmitting continuously and measuring the velocity via Doppler effect. With the help of Doppler effect, we will measure the velocity and in the frequency shift, right? Frequency modulated continuous wave radar, measuring both range as well as the velocity using frequency modulation, right? Based on functionality, search radar are there, right? This is based on the functionality. Search radar is scanning the large number of area to locate the target. Tracking radar, they will continuously monitor the target. Imaging radar, produce a detailed map or image, right? Based on antenna scanning, that is mechanical scanning radar, and phase array radar, right? Based on frequency band, we are having L band radar, that is having frequency 1 to 2 kilohertz, that is a long range surveillance radar, will work in that one. S band, we are having 2 to 4. Weather and ship radar generally use that one. C band is airborne radars, that is working at the frequency of 4 to 8 kilohertz. X band radar, that is 8 to 12 gigahertz, I think this frequency, not kilohertz, gigahertz. the military tracking and police radar, and then KU and KA band, that is 12 to 40, that automatic and satellite radar. Based on application, there are airborne radar installed on an aircraft for navigation, right? Then marine radar, that is used for coastline and ships, used to detect the ships in coastline areas. Ground based radar used for air defense and traffic control. Spaceborne radar installed on satellite to remote sensing and earth observation, right? These are the things. The continuous wave radar, continuously transmitting, right? The continuous wave radar is simplest form of radar which transmitted continuous time signal and simultaneously receive the echo reflected from the target. Unlike pulse radar, it is cannot measure the range directly because there is no timing difference between the transmitted and reception. However, we can accurately measure the velocity by using the Doppler effect. So this is based on Doppler effect. This is the block diagram. Principle is the frequency shift, that is equals to 2v by lambda. V is the speed of object and lambda is the wavelength of the wave which we are sending to that one, right? Transmitting continuously, right? Yeah, this signal hits the moving target and reflect back with the frequency shift proportional to the velocity, mixing the receiving component and transmitting receive frequency to produce the Doppler beat frequency. Advantage: simple and inexpensive in design. Very accurately you can measure the velocity with the help of this one. Compact and power efficient. Disadvantage: cannot measure. We cannot measure the range that this object is at that much distance to us, right? And these are the advantage. And application: police speed radar, and like that we'll be using this one. Next is pulse radar. I already discussed this pulse radar. We transmit one pulse, then wait for the echo, then we transmit the next pulses. That is the already discussed with you, yeah, in detail. These are the R maximum, right, range and everything. These are the advantages and disadvantages and application of this radar, right? Examples: the pulse radar, this is the maximum range you can detect that one. And frequency modulated radar, this is the block diagram for that one, right? FM transmitter, receiver, and everything is there. Working principle, right? It transmit, this is most important, it transmitted a frequency which increase linearly with time, right? We transmit a frequency which is linearly increase or decrease with time. The echo received from the target is delayed by time t, right, resulting in frequency difference. That difference is given by delta f. The frequency difference is proportional to the range. R is equals to c delta f by 2s. S is the slope of frequency modulation, right? How much frequency you directly changing. If the target is moving, the received signal is experience a Doppler shift also, allow the simultaneously range and velocity calculation from that one. These are the advantage and disadvantage of this one, and this is one example where we calculate the right. Next one is Doppler effect and moving target indication, right? Doppler effect, what is the Doppler effect? Doppler effect refers to the apparent change in frequency of a wave when there is relative motion between the radar and its target, right? There will be a frequency, and how much is that frequency deviation? That is Fd is equals to 2v by lambda. Fd is Doppler frequency and v is the relative frequency between radar and target, lambda is the wavelength of transmitted, right? These are the two factors. Moving target indication radar, right? MTI radar. MTI radar system is used the Doppler effect to separate the moving target from the stationary target. So basically what is happening, if you are tracking a object, you are transmitting a signal towards that object reflect back, but some stationary objects are also there, buildings and like that, they are also reflecting that signal. So we are receiving multiple signals. So how you can differentiate between a stationary and the moving target? That will be based on this moving target indication radar, right? It separates the moving target from the stationary objects such as buildings and sea area. Now working principle: radar transmits a sequence of pulse Right, receive, compare the phase of consecutive echoes using delay line cancellation. The phase difference is 0, the signal is cancel out. Phase difference is 0 means the signal which will receive continuously from the same object, that will have the phase difference 0, right? If a object is moving, that phase have a different phase difference, right? So we will cancel out that object whose phase difference is 0, we will remain only that object which is having different phase defect, right? With the help of that one we can easily calculate the moving target, right? MTI improved technology, these are the MPI improved technology, coherent oscillator, digital signal processing, and pulse Doppler radar application. That is the application of this one, right? And next thing is systematic aperture radar, right? SAR radar. Generally synthetic aperture radar is the advanced form of radar, right? Used primarily for high resolution imaging of earth's surface. Unlike conventional radar rely on the large antenna for fine resolution, SAR achieves superior resolution by synthesizing a large virtual aperture through the motion of a radar platform like aircraft and satellites, right? Principle, SAR is used to movement of a radar antenna over a target area. Now the target means we are moving the radar with the help of aircraft or satellite over an area. That time we are not sending much power or much, and you can say that larger antenna for that purpose, right? Larger antenna aperture, by combining multiple echo signal received from slightly different position, it will create an image which is exactly fine spatial detail. The resolution is lambda r by 2l r, the resolution from that one. Yeah, that is satellite we are sending, we receive, we will make a image for that one. Next is phase array and electronic scan radar, right? Like the traditional radar are mechanically rotated. When you see the radar antenna, they will be mechanically rotated previously, but now we are using the phase array. In phase array you can send the signal in any direction, but just as adjusting the you can say the what was that, the angle, something like that, right? So with the help of that one we can easily change its slope. It be transmitted in that direction, you can transmit other directions also with the help of that one, right? Each antenna element is the array transmitting a signal with a controlled phase shift, right? By adjusting the phase shift, the direction of main lobe is changed. That's the phase shift, right? The main lobe direction is changed without moving the antenna, right? That this will give you the main lobe direction, right? The phase shift between the adjacent element and everything. Type of phase, the passive electronic scan array and active electronic scan array. These are the advantage and disadvantage. You can go through this one, right? The radar signal processing, and we will receive the signal from the radar echoes. We analyze that one by using the computer softwares, and we will make everything about that. Key processes state detection and amplification, then filtering and noise separation, pulse comparison, Doppler processing, clutter rejection, and tracking and data diffusion. Then we will go the final result from that one, right? These are the modern techniques which are used, machine learning and waveform diversity, MIMO radar, right? Application of radar, these are the application: military, defense and aviation, marine, meteorology, automotive, space and remote sensing, industrial and biomedical. These are the current use of you can say the application of radar, and these are the some questions from the radar, right? I will share this file in the group, you can check there, right? These are the some question. I think it's 20 questions from there, from the radar. You can watch that and see these questions and solve them, right? So this is the complete discussion about types of radar and everything. So if you want to prepare, like we are discussing these things and we are also giving the live classes, you can join the live classes at Yourpedia Education. So hopefully this will help you in your exam. Thank you.